Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about absolute extrema.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, y equals a negative x to the third power minus 6x squared minus 9x plus 3, and we want to find the points of absolute minima and maxima on our closed interval from negative 3 to negative 1. The first thing I need to do here is find the derivative. Okay, so I'm going to take my derivative, or find my derivative, call it f prime of x, and we're using our power rule. 3 comes down, negative 3x squared, subtracted by 1 here, and then 2 times 6 is 12, so we have a negative 12 here, x, so subtract the exponent by 1, which is a 1, and then we just have a minus a 9 going on here. Hopefully you know your derivatives by now. From there, let's go set our derivative equal to 0. We have a negative 3x squared minus 12x minus 9 equals 0. And now we're solving for x here. I pulled out a negative 3 from all parts here, and so negative 3 comes out. We have an x squared here, then plus a 4x, and then a plus a 3 equals 0. Divide both sides by negative 3, and we basically can just eliminate that. So we have an x squared plus a 4x plus 3 equals 0, and now we need to, well, factor. So to factor this, we find what multiplies by 3 as before, and we have an x plus 1 and an x plus 3. Now we can set each part equal to 0. X plus 1 equals 0, and x plus 3 equal to 0, and solve, and x is an easy negative 1 and a positive 3. Or sorry, negative 3. Almost messed that one up right there. Okay, so we have a negative 1 and a negative 3 here. Now notice they are the 2 points of our endpoints on our closed interval right there. So when that happens, we just need to find what these values are. So we need to check the critical points, which these are our critical points, and then they're also the endpoints of our interval. So to do that, we find what f of negative 1 is, plug into our original equation, and that came out to be a positive 7. We have f of a negative 3 in our original equation, and that came out to be a positive 3. And so these are our absolute minimums and maximums, and so our absolute minimum is the coordinate point negative 3 comma 3. It's the less of the two here, right, less y value, and the absolute maximum here is that coordinate point negative 1 comma 7. So again, our final answer here is absolute minimum at negative 3 comma positive 3, and absolute maximum at negative 1 comma 7. We're given this problem right here, y equals an 8 divided by x squared plus 4, and we want to find all points of absolute minima and maxima on our closed interval from 0 to 5. Now the first thing I like to do is find my derivative here, and actually I rewrite my function like so, because I find it easier to find the derivative this way. 8 times an x squared plus 4 now to the negative 1 power. From here we use our power rule and a chain rule here to find our derivative. 8 stays out front, bring down the negative 1, keep the inside the same, x squared plus 4, and our exponent is subtracted by 1, negative 2. Multiply by the derivative of the inside, which is a 2x. Now from here, let's go simplify this up a little bit. We have f prime of x here, and we multiply it out. 8 times negative 1 is a negative 8, times the 2x is a negative 16x. The denominator, we bring this down, an x squared plus 4, all to the positive 2 power now that it's in the denominator. From there, let's go find our critical values. We're going to set the numerator and denominator equal to 0. Negative 16x equals 0, and we have an x squared plus 4, all squared, equals 0. Well, this one's easy. Divide both sides by negative 16, x equals 0. Square root both sides, gets rid of this second power, but it's 0 here, so we have an x squared plus 4 equals 0. Subtract the 4 to both sides, x squared equals a negative 4, and square root both sides, x equals a plus or minus the square root of a negative 4, which is an imaginary number which is out of our domain. So we don't need that right there. So the only value we're really looking at here is 0. It's the only critical value. So we need to test the critical value as well as our endpoints of our interval because they're closed. But look, 0, is written twice. Okay, so let's go check the endpoints to see if there are minimum or maximum there. We find f of 0 and an f of 5. Well, f of 0 I found into our original equation came out to be a positive 2, and f of 5 is an 8 over a 29. 8 over 29 is the lesser of the two, so it's our absolute minima, and, well, 2 is larger, so it's our absolute maxima. So we have an absolute minimum at the coordinate point of 5, 8 over 29, and an absolute maximum at the coordinate point 0, 2. And again, that's our final answer. We're given this problem right here, y equals x to the third power plus 6x squared plus 9x plus 3, and we want to find all points of absolute minima and maxima on our closed interval from -4 to 0. Now, I first want to find my derivative. So f prime of x here, let's use our power rule. 3 comes down, 3x squared, subtract the exponent by 1. 2 times 6 is 12. 12x, subtract the exponent by 1 is 1, and then plus just the 9. The rest, derivative constant, is 0. We take our derivative and we set it equal to 0 and solve to find our critical values. 3x squared plus a 12x plus a 9 equals 0. From there we can pull out a 3 from all parts here. 3x squared plus a 4x, 3 out of 12 is 4, and plus 3 out of 9 is, well, 3. Now we divide up both sides by that 3 here, and well, that kind of cancels it. So we have an x squared plus 4x plus 3 equals 0, and that can factor. Okay. Now we factor it here. Two numbers multiplied by 3 but add to be 4 are a 1 and a 3 being positive. We set both of those equal to 0, x plus 1 equals 0, and you know how to do this. And solve. X equals a -1 and x equals a -3. Now, we first now want to check are both of these within our interval, and yes, they are. Okay, so since both are in our interval, these critical values, and we have a closed interval from -4 and 0 here, we need to check all the values, the critical values we found, as well as the endpoints there. Okay, so to do that, we have our f of -1, and what's the order? F, I did -3, I did it out of order here. F of -4 and f of 0. F of -1 came out to be a -1. F of -3 came out to be a +3. Again, plugging into our original equation. F of -4 is -1, and f of 0 is a +3. Notice we have a repetition here. Our two lowest values and our two highest values are the same. And so in this case, our absolute minima and maxima have two answers for each. Our absolute minimum is a -4, -1, and a -1, a -1. Our absolute maximum has the 2 points of 0, 3, that's a 3, and a -3, a +3. And so again, our final answer here is absolute minima at -4, -1, and -1, -1, as well as our absolute maxima at 0, 3, and -3, 3. We're given this problem right here, y equals x to the fourth power minus 3x squared plus 4, and we want to find all points of absolute minima and maxima on our closed interval from -1 to +1. The first thing I like to do is find my derivative. F prime of x here is equal to power rule, 4 comes down, x to the third power minus 2 times 3 is a 6, x, and then derivative of the constant is just the 4. I take my derivative and set it equal to 0. 4x to the third power minus 6x equals 0. Pull out an x here, and we have x times a 4x squared minus 6 equals 0, and we can set both parts individually equal to 0. X equals 0, and a 4x squared minus 6 equals 0. Add a 6 to both sides, and we have 4x squared equals a +6. Divide both sides by 4, and x squared equals 6 divided by 4, or 3/2. Square root both sides, and x equals a plus or minus the square root of 3/2. Now one thing we want to check is with these critical values that we found, are they within our domain, our interval here? And square root, or plus or minus the square root of 3/2 is just outside of this domain. So we don't have to worry about them. We just have to worry about the 0 and our endpoints of our domain. So let's go find what happens when we plug them into our original function. F of -1 is a positive 2. F of positive 1 is a positive 2 as well. And f of 0, the critical value, plugged into our original equation, is a positive 4. So what does this tell us? Well, that means we have two minimum values that are the same at a y value of positive 2, and one maximum value when y is 4, or a maximum value of 4 when x is actually 0. So our absolute minima, right, the smaller y value here is at -1, 2, and 1, positive 2, right? Our absolute maxima on our interval is 0, 4. So again, our final answer here is the absolute minimum at -1, 2, and positive 1, 2, and our absolute maxima happens at 0, 4. We're given this problem right here, y equals x squared over 3x minus 6, and we want to find all points of absolute minima and maxima given our closed interval of 3, 6. Now, first thing I like to do is find my derivative here. So what is f prime of x? Well, using our quotient rule, derivative of the numerator is a 2x, multiply that by the denominator, 3x minus 6, minus the derivative of the denominator, which is just a 3, times the numerator, x squared, all over our denominator squared, 3x minus 6, all squared. From there, we need to simplify this a little bit, so we have f prime of x here, and we multiply this out. 2x times a 3x is a 6x squared, and 2x times a minus 6 is a minus 12x. And 3 times x squared is 3x squared, so we subtract 3x squared here. All over that denominator squared, 3x minus 6, all squared. From there, we keep on simplifying. 6x squared minus 3x squared in the numerator is just a 3x squared minus a 12x, all over a 3x minus 6, all squared. Okay, now we're at a point where we want to find our critical values. So we're going to set the numerator and denominator separately equal to 0 and solve. 3x squared minus a 12x equals 0, and we have a 3x minus 6 all squared equals 0. That's being the denominator. Alright, pull out an x here, and we have a 3x minus 4, minus a 12, getting ahead of myself here, Sean, equals 0. X equals 0, set both parts equal to 0, and 3x minus 12 equal to 0. Well, add a 12 to both sides, and 3x equals 12. Divide both sides by 3, and x equals that 4 I was mentioning. From here, square root both sides is just a 0, so we have 3x minus 6 equals 0. Add 6 to both sides, 3x equals 6, and divide both sides by 3, and x, well, 6 divided by 3 is a 2. So we have three values here, 0, 4, and 2, and we want to see, well, which ones are actually within our interval, in our domain. And, well, 4 is in it, but 0 is outside of our domain, and same with 2. So the only value I need to check now is 4 is a critical value, as well as our endpoints. So we find what f of 4 is, and I plug that into my original equation, and I get 8/3. F of 3, the endpoint, we get a positive 3, and f of 6, the other endpoint, came out to be a positive 3 as well. So notice we have the largest maximum value here at both 8 and 3, and our minimum value, absolute one, is 8/3. And so to write it out, our absolute minimum, the coordinate point, is 4, 8/3. And our absolute maximum value is 3, 3, as well as a 6, 3, and that is our final answer. We're given this problem right here, y equals x plus 2 all to the 2/3 power. And we want to find all points of absolute minima and maxima given the closed interval of -4 to -2. First thing I want to do is find my derivative. So f prime of x here is equal to 2/3 comes down. Inside is x plus 2. Exponent gets subtracted by 1, so it's a -1/3 now, multiplied by the derivative, or by the derivative inside, which is just a 1. This simplifies out to be f prime of x equals a 2 is the lonely numerator. The denominator is 3, and then the 1/3 comes down with the exponent to be a 3rd root of, and it's positive now, an x plus 2. So we want to find our critical values, and so what I do here is really, I look what causes some issues, and if the denominator is equal to 0, we have an issue. That's what we're really looking for. So I set the denominator equal to 0 and solve for what x value produces that. So we have 3, 3rd root of an x plus 2 equals 0. Well, I divide both sides by 3, and I just get the 3rd root of an x plus 2 equals 0, right? And I cube both sides, and the same thing really happens. That 0 is magical that way. So we have an x plus 2 equals 0, and x equals a -2 value. And luckily, a -2 is just within our domain, our interval. It's a closed interval, so -2 is included. So we need to check, well, that critical value, which is also the endpoint, but the endpoints of our interval. So we have f of -2, and we're plugging into our original equation, and that comes out to be a 0. F of a -4, though, when plugged into our original equation, is the 3rd root of 4. So we have 3rd root of 4 and 0. Well, clearly 1's the minimum and 1's the maximum, right? 0 is less than the 3rd root of 4. And so our absolute minimum here is a -2, 0. And our absolute maximum, my marker is still alive after this, is a -4, 3rd root of 4. And that is our final answer. We're given this problem right here. Y equals x to the 3rd power minus 3x squared minus 3. We want to find all points of absolute minima and maxima on our given interval from 0 to 3, but not including those values. First thing I want to do is find my derivative. F prime of x here is equal to power rule 3 comes down, x squared. Minus 2 times 3 is the 6, x to the 1st power, and derivative of -3 is a 0. Excuse me, we take this derivative and we set it equal to 0. 3x squared minus 6x equals 0, and we're solving for x here. I pull out an x, and I have a 3x minus 6 equals 0 here. We set both parts individually equal to 0. X equals 0, and 3x minus 6 equals 0. Solving for x, add a 6 to both sides. 3x equals a 6. Divide both sides by 3, and x equals 6 divided by 3, which is a 2. So now we want to look, we use these two critical values to see which one is really within our interval and could be an absolute minima or maxima. We don't need to check 0. It is not within our interval. It just missed it. So 2 is the only one we really need to look at. So let's do a little test here. Our first derivative test. And we plug in values into our derivative left and right of 2. But remember, it's within the interval, so I don't want to make sure it's bigger than 0 and less than 3 for each one. So between 0 and 2, I chose a, what did I choose? A 1. So I found f prime of 1 here, and it came out to be a -3. I just care that it's negative, and so we're decreasing here. Between 2 and 3, I picked a 2.5, so f prime of 2.5, and that came out to be a 3.75. That's a positive value, and we're increasing. So if we go from decreasing to increasing, right, decreasing to increasing on that interval, we have a minimum value. Now, is it an absolute minimum? Well, think about this. Within the whole interval from 0 to 2, we're decreasing, and then at 2, we then increase. We can see that actually on the graph there. And so this is actually our absolute minimum, our lowest value within our interval. And so when we plug that in, f of a 2 value, all right, f of 2, plug it into our original equation, we get a -7. And so our absolute minimum is the coordinate point 2 comma negative 7. And for an absolute value, there is no absolute, or not value, absolute maxima. There is no absolute maxima on this interval because it keeps increasing all the way to 3 but doesn't equal 3, and then that's it right there. So again, our final answer here is we have an absolute minima at 2, negative 7, or 2 comma negative 7, and we have no absolute maxima. We're given this problem right here, y equals a 5x plus 25 to the 1/3 power, and we want to find the points of absolute minima and maxima on our interval from negative 2 to 2, and it's a closed interval. First thing I want to do is find my derivative, f prime of x here, and we're using the power rule and chain rule. 1/3 comes down, and we have a 5x plus 25 here, and the exponent gets subtracted by 1, and so we have a negative 2/3 here. Multiply that by the derivative of the inside, which is just a 5. From there, let's simplify this. F prime of x is equal to, well, 1 times 5 is 5 in the numerator, and the denominator is just 3, and then we have 2/3 comes down, with the positive exponent in the denominator, and so that 5x plus 25 is squared, but we also want to take the third root of the whole thing. Okay? Alright, so now we want to find our critical values, and this happens when we're undefined or when it's equal to 0. Well, really the only thing happens when our denominator is equal to 0, which makes it undefined. So let's find out where that happens. 3 third root of a 5x plus 25 squared equals 0. Well, luckily, right off the bat, divide both sides by 3, cancels out, 0 divided by 3 is just 0. If I raise both to the third power here, like this, what are we left with? 5x plus 25 squared equals 0. Take the square root of both sides, same thing. That's the beautiful thing about 0, which is 0 a lot. So 5x plus 25 equals 0. Subtract a 25 to both sides, and 5x equals a negative 25. Divide both sides by 5, and we have x equals a negative 5 right there. So before we get hog wild and deal with negative 5, notice that it's outside our interval. And it's outside of our interval, so we can't really use it. After all that work, it was pointless. So now we just need to test the endpoints of our interval here. Okay? So the endpoints of our interval, we have f of a negative 2, and that comes out to be, plugged into our original equation, our 3 square root of 15, and f of a positive 2 on our interval is 3 square root of 35. Okay? So now we have, well, 3 square root of 35 is larger than 3 square root of 15, and so our absolute maxima is at 3 square root of 35, and absolute minima is 3 square root of 15. So we write as a coordinate point, our absolute minimum is the coordinate point negative 2 comma 3 square root of 15, and our absolute maximum is the coordinate point 2 comma 3 square root of 35, and that is our final answer. We're given this problem right here, y equals x to the third power minus 3x squared plus 6, and we want to find all points of the absolute minima and maxima on our given interval from 0 to positive infinity. Infinity, I said that one weird. Anyway, first step, find the derivative. So we take our function, find the derivative, we're using the power rule. 3 comes down, x squared. Minus 2 times 3 is a 6, x, and then derivative of 6 is just, well, 0. We take this derivative and we set it equal to 0 to find our critical values. So 3x squared minus 6x equals 0, and let's solve. Well, I can pull out an x here, and I have 3x minus a 6 equals 0. Set both parts equal to 0, x equals 0, and 3x minus 6 equal to 0. Add a 6 to both sides, 3x equals a positive 6, divide both sides by 3, and x equals 2 here. Now both of these critical values are within our interval from 0 to positive infinity, but it's going to be a little different when we do the first derivative test here because, well, we don't have any values less than 0 within the interval. So I like to do this when I draw it sometimes, just to kind of show you what we're doing here for the first time, but then I cross this off. This part doesn't matter. We have 0, we have 2, and we go to positive infinity. So I do my first derivative test, and I plug in a value between 0 and 2, and I have f prime of 1 I pick, alright, plug into my derivative, and I get a -3, and I just care that it's negative, and so we are decreasing on the interval. I pick a value larger than 2, which was 3, so f prime of 3, so I put 3 into my derivative, and I got a 9. I just care that's positive, and we're increasing on that interval all the way to positive infinity. So what does this tell us? Well, we're decreasing and then increasing right there. So we're decreasing here at 2, then we're increasing afterwards, so we have a minimum going on there. And then at 0 though, right? So at 0 we have a high value, right? It's at 0, it's decreasing, x is 0, and then at 2 it turns to increasing, but it's increasing forever to positive infinity. So we need to check our endpoints here and the critical value, and really just that one endpoint. F of 0 came out to be a positive 6. That's the endpoint value, but the minimum value, the relative one, f of 2, came out to be a positive 2, which is less than 6. And so our absolute minimum here, it occurs at a 2, 2. And as regards for absolute maximum, we don't have any because it's going on forever to positive infinity, so we have no absolute maxima. So again, our final answer here is our absolute minimum is 2, 2, and we have no absolute maxima. We're given this problem right here. Y equals an x to the 4th power minus 2x squared minus 3, and we want to find all points of absolute minimum and maxima on our given interval from 0 to infinity, and notice the parentheses there. First step, I want to find my derivative. So we find f prime of x here, let's call it, and we're using our power rule. 4 comes down, x to the 3rd power now, minus 2 times 2 is a 4, x, well, subtract 1 is 1 power, and the derivative of -3, since it's a constant, is just 0. Now, I want to set my derivative equal to 0 to find the critical values. So 4x to the 3rd minus 4x equals 0. And now we're solving. Let's pull out an x here. And we have an x times a 4x squared minus 4 equals 0. Set both parts equal to 0. X equals 0. And 4x squared minus 4 is now equal to 0. Solving here, I add a 4 to both sides. 4x squared equals a 4. Divide both sides by 4, and x squared equals a positive 1. Square root both sides, and well, we got plus or minus square root of 1, which is just 1, so x equals a plus or minus 1. Okay. So now we have to look which values are within our interval here. Well, 0 is actually not in our interval. Remember, it's not included with that parenthesis, so we don't need to worry about that. -1 is outside of the interval as well, so we don't worry about that. But +1 is within our interval. Okay, so we're going to use that value here. So I like to make this kind of like a first derivative test here. I have a 1 here, 0, and notice nothing to the left of it. And I know I'm not going to include 1. And let's go see what's going on. I pick a value between 0 and 1. I picked 0.5, and f prime of 0.5, plug into my derivative, and I get a -1.5. I just care that it's negative, and so we are decreasing here. Okay? I picked a value that was larger than 1, and I picked 2, so f prime of 2 within the interval, and that's a 24, and again, plugged in the derivative here, but it's positive, so we're increasing. So our function is decreasing, then increasing at 1, we have a relative minimum, relative minimum there. I wrote maximum on my paper. That would be incorrect. And so, we're decreasing there to increasing. All right. Now, this endpoint we can't actually have as a value, as an absolute value, because you can't, or absolute maximum or minimum, because it doesn't really equal that. So I just need to check this f of 1 here. F of 1 at that value here is a -4. And we know that's actually the absolute max or absolute minimum, because to the left of it we're decreasing down to it, and afterwards we're increasing up to positive infinity. And so that is our absolute minimum. So our absolute minimum here is a 1, -4. And as far as absolute maxima, we actually don't have one because it's going up to positive infinity forever. We can't really hit that value or state it. So we have no absolute max. So again, my final answer here is absolute minimum of 1 comma negative 4, and an absolute maximum, well, we don't have any there. We're given this problem right here, y equals 4 over x squared plus 2, and we want to find all points of absolute minima and maxima on our given interval from negative 5 to negative 2, but not including negative 5, but we are including a negative 2. First thing I want to do is find my derivative here to find our critical values. Now I like to rewrite my function here, f of x, like so. I find it's easier to find the derivative. 4 times an x squared plus 2 to the negative 1 power. Now with our derivative, f prime of x here, 4 stays there, negative 1 comes down, multiply with the inside, x squared plus 2, subtract the exponent by 1, power rule here, negative 2. Now apply the chain rule, derivative of the inside, which is a 2x. From there, we need to simplify this bad boy here, so f prime of x, and 4 times a negative 1 is a negative 4, times 2x is a negative 8x. All over, I'm going to bring this down to the denominator, and x squared plus 2, all squared. Okay? Now, since we want to find the critical values, we're going to see where we're equal to 0 as well as undefined. So I'm going to set my numerator, negative 8x, equal to 0, and our denominator, x squared plus 2, all squared, equal to 0. Divide both sides by negative 8, that's easy, x equals a 0. Square root both sides, and we have, well, x squared plus 2 equals square root of 0, which is 0. Subtract 2 to both sides, x squared equals a negative 2. Square root both sides, and we have x equals plus or minus square root of negative 2, and that is imaginary, which is clearly not in our interval or domain here. So we can't use those values. And no, it's also not in our interval. That's 0. 0 is not in the interval as well. So we can't use either one. Nothing is in our domain here, okay? So how do we really apply the first derivative test? Well, look at this. I'm going to put a 2 here, or negative 2. And we're going to go here to like the closed interval here to negative 5. Okay? And I'm still going to kind of apply my first derivative test and see what's going on here. Okay? Well, between negative 5 and negative 2, I'm going to pick a value between those two values, which is negative 3. And I'm going to find what f prime of negative 3 is. And that came out to be a 0.19835 approximately. But it's positive. That means on the interval we are increasing. So what does that tell us? That tells us on our interval our lowest value is right after negative 5, but we don't actually have a lowest value. We can't say it's an absolute value there because it's not an endpoint, that's a bracket. But it's increasing all the way to when x is negative 2, and we can include that. So negative 2 would be our absolute maximum, the x value. So we want to find the y value there. So we use our original function, f of negative 2 here, and we plug that into our original function, and I get a 2/3. And so what does that tell us? Well, we don't have an absolute minimum value here, right? But we do have an absolute maximum value at the coordinate point negative 2, comma 2/3. So again, our final answer here, we have no absolute minimum value, but we have an absolute maximum value at negative 2, comma 2/3. We're given this problem right here. Y equals a negative 1/6 times x plus 1 to the 7/3 power, plus 14 over 3 times an x plus 1 to the 1/3 power, and we want to find all points of absolute minima and maxima on our given interval from negative 5 to 0. The first thing I want to do is find my derivative, and this one's a doozy. F prime of x here, but we take our time. Negative 1/6 stays out front, bring down the exponent 7/3. Multiply by the inside, that x plus 1. Exponent gets subtracted by 1, and 7/3 minus 1 is a 4/3. Multiply the derivative of the inside, which is just 1. Plus 14/3 times, exponent comes down a 1/3. The inside is an x plus 1. The exponent gets subtracted by 1, and 1/3 minus 1 is a negative 2/3. And multiply by the derivative inside, which is just a 1. From there, let's go simplify what we can. Okay. Well, negative 1 times a 7, okay, up here negative 1 times 7 is a positive set, or negative 7, I don't even know any of that. And then we have an x plus 1 to the 4/3 power over, that's 6 times 3, 18 in the denominator. And I'm going to leave some space here because I'm going to use that in a minute, plus 14 times 1 is that 14 in the numerator, okay? Denominator, 3 times 3 is 9, and then we bring down this x plus 1 to the, in the denominator and have it to a positive 2/3 power, okay? Now these are just fractions, and when we add fractions we need to have a common denominator. So what do? Well, I want to have an 18 here on this side, so I'm going to multiply this half here by a 2 over 2. 2 times 2 would give me that 18. The first fraction I'm going to multiply, I have the 18 now matched up, but I'm going to multiply it by an x plus 1 to the 2/3 power over itself. Same technique when we add just normal fractions, just with some expressions now. Then from here we simplify. F prime of x is equal to, well, multiply this kind of out here. We have negative 7, we have an x plus 1 right there, and we add the exponents, and so we have 6/3 now. Alright, same base, add the exponents. Plus, because it's all going to be under one big thing, 14 times 2, which is a 28. All over this 18 times an x plus 1 to the 2/3 power, which is our common denominator. From here, we're going to simplify this slightly. I'll kind of zigzag a little here to use all the space we can, because we'll need it. Alright, there we go. Okay. Well, multiplying this out, well, 6/3 is just the same thing as a 2 power, right? 6/3 is the same thing as a 2 power, so I'm going to remove that and put a 2 right here. Then from there, since it's squared, let's go multiply that out. Negative 7 times, we have x times itself is x squared, plus that comes out to be a 2x plus a 1, as such. Okay? And then we have the plus 28, almost at 18, over an 18 down there, and an x plus 1 to the 2/3 power. Let's keep simplifying. Let's do the f prime of x right here. Okay, zigzagging back over here so we can kind of see that, just so you know where it's coming from. Alright, multiply the negative 7 across. Negative 7 times x squared is a negative 7x squared. Multiplied by the 2 is negative 14x. And then negative 7 times 1 is a negative 7 plus 28 over 18 times an x plus 1 over 2/3. Can't forget that. Keep on simplifying, combine our like terms. Negative 7 and 28, it's a positive 21. So negative 7x squared minus 14x plus a 21 all over 18 over x plus 1 to the 2/3 power. Okay. It's at this point we want to, well, find our critical values. We set it equal to 0. So we're going to numerator and denominator each equals 0. Numerator is when it's equal to 0, denominator where it's undefined. So we have a negative 7x squared minus 14x plus 21 equal to 0. And then the 18 times the x plus 1 to the 2/3 power equal to 0. Okay? Alright, let's deal with this one first. If I pull out a negative 7 from all parts, I'm left with a positive x squared plus a 2x plus 3 equals 0, and that's a little easier factor. Divide both sides by negative 7, we can just eliminate that. This factors right here equal to 0, and it's an x plus a 3 and an x minus a 1. Set them equal to 0, x plus 3 equals 0, x plus 1 equals 0, and so x, we can see, equals a negative 3, this is a minus 1, negative 3 and a positive 1 right there. The second part here, we set equals 0, divide both sides by 18, don't really need that. We can multiply both sides to the 3/2 power to eliminate that, and 0 is being wonderful, it's just still 0. So we have x plus 1 equals 0, and x equals a negative 1 there. So we have 3 values here to test, and we want to see if they're actually within our interval. Well, 2 of them are, but this one right here is not in our interval. It's just outside that negative 5 to 0. And so doing my first derivative test, we want to make it a little kind of nice, a little different here. -5, -3, and -1, as well as endpoint of 0. But we know we can't really include that, so let's put like a little parenthesis kind of showing where we're at there. Okay? So I'm going to pick a value between -5 and -3 and plug it into my derivative, which we found, and see what it comes out to be. And I picked f prime of -4. I didn't give myself much room, but it's equal to approximately -0.9348. And it's a negative, so we are decreasing on that interval. Okay? To give myself a little more room, put a little arrow here. Between -3 and -1, I found f prime of a -2, and that came out to be approximately 1.1667. That's positive, that's what I really care about, and we're increasing there. Between -1 and 0, I picked a -0.5, so f prime, again, f prime of 0 or -0.5, and that came out to be a positive 2.315. I just care that it's positive and we're increasing. So what's going on here? Well, within this interval from -5, we're not including -5, but right afterwards we start decreasing down to -3. Then we increase to -1, and then we keep on increasing to 0. And so -3 is actually going to be our absolute minimum here, because it's everywhere to the left is decreasing towards it, and after that it keeps going up. So we have our absolute minimum happening at -3, and nowhere else we can claim we have an absolute maxima, because we can't have maximas at our endpoints, and we don't even have a relative minimum maximum going on here at -1. And so we have a absolute minimum at the coordinate point, and I found that here, f of f of -3 came out to be a -4 third root of 2. So our absolute minimum happens at the coordinate point, -3, comma, -4 third root of 2. And plug into our original equation, and we have no absolute maxima going on here. So again, our final answer, an absolute minimum at -3, comma, -4 third root of 2, and we have no absolute maximum. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.